Alright, now let's examine what are the different types of filters. Filters can be placed into broad categories that correspond to the general characteristics of the filter's frequency response. If a filter passes low frequencies and blocks high frequencies, it is called a low-pass filter. If it blocks low frequencies and passes high frequencies, it is a high-pass filter. There are also bandpass filters, which pass only a relatively narrow range of frequencies, and band-stop filters, which block only a relatively narrow range of frequencies. Filter circuits such as low-pass filter, high-pass filters, bandpass filters, and band-stop filters shape the frequency content of signals by allowing only certain frequencies to pass through. It's possible to visualize the behavior of an electronic filter by looking at its frequency response graph. The x-axis is the frequency and the y-axis is the amplitude. The behavior of a low-pass filter is shown in this diagram. Let's say we have a signal generator that will generate a sine wave starting from 1 Hz all the way to 1 MHz, and this sine wave will have to go through a low-pass filter. Looking at this diagram, we can see that after a certain frequency, our filter will start blocking our sine wave signal by reducing its amplitude. After this frequency, let's say 700 kHz, our low-pass filter will block completely all the signal which has this frequency or higher. In case of a high-pass filter, low-frequency signal will be blocked, meaning that its amplitude will be 0, and after a certain frequency, our high-pass filter will start allowing signal to pass. A bandpass filter has 2 frequency limits, which delimits the signal that can pass through the filter. A band-stop filter has 2 frequency limits as well, but it delimits the signal that will be blocked. Filters can also be classified according to the types of components that are used to implement the circuit. Passive filters use resistors, capacitors, and inductors. These components have no ability to provide amplification, and consequently, a passive filter can only maintain or reduce the amplitude of an input signal. An active filter, on the other hand, can both filter a signal and apply gain, because it includes an active component such as a transistor or an operational amplifier.